Okay, so let's tackle this question, ladies and gentlemen. It says below is a pulley. So this is a pulley system, and we have three questions. All right, it says find the velocity ratio, mechanical advantage, and the efficiency of the system. Now, this is the effort given. Let me just do this. All right, so we have the effort given here, and we have the load. The effort is 60 newtons, and the load is 150 newtons. How do we find the velocity ratio? All right, and how do we find the mechanical advantage and the efficiency? So, follow me. First of all, to find the velocity ratio, okay, to find the velocity ratio, count how many number of pulleys do you have. The number of pulleys that we're talking about, we have this larger one and the smaller one and another smaller one. That will give you the velocity ratio. Okay, so we are saying part A, velocity ratio is just equal to what? 3. You don't have to put units. Velocity ratio, remember, it's a ratio, so it does not have units. All right, so we are done with the velocity ratio. All right. Another way you can find velocity ratio in case the number of pulleys are not given, maybe just a statement, you can look at the distances. All right, the distance moved by the effort over the distance moved by the rod will give you the velocity ratio. We go to B. B says the mechanical advantage. Now, mechanical advantage, it relates to the load and the effort. All right, mainly with the input and the output. Now the input is what is here and the output is that one, the effort that we're putting in. So mechanical advantage is given by the load divided by what? The effort. Okay, so this one, let me just write in, say, number of pulleys. All right, so mechanical, which one is the load? It's 150, right? Newtons over the effort was given to be 60. We're going to put 60 newtons. So all what we need is to punch that one on the calculator. So let's go. So 150 we divide by 60. I'm getting 2.5. 2.5. Now, can you see something? The mechanical advantage is 2.5 and the velocity ratio is 3. Now here's the thing. In most cases, there are only two situations. The mechanical advantage should always be less than or equal to the velocity ratio. What am I trying to say? I'm saying mechanical advantage should be what? Less than or equal to what? Velocity ratio. This is a very important law or rule for energy conservation and also efficiency calculations. All right, so let's now go to calculating of efficiency. And to calculate efficiency, so efficiency is equal to mechanical advantage over velocity ratio multiplied by what? 100. So what is this animal called efficiency? Efficiency, it just shows you how efficient a machine is in terms of what has been put in and what has been put out. All right, in the ratio of the mechanical advantage and the velocity ratio. So what is our mechanical advantage? 2.5. It also doesn't have units, by the way, so just end it there. And 3 multiplied by what? 100. So say over 3 multiplied by what? 100. I'm getting 83.3333. So physics, whether they have told you, in most cases when they haven't told you to how many decimal places, leave it to one decimal place. So we have 83.3%. Now, sometimes they can ask you, where has the other 16.7, where has it gone? Well, that's the question that now you need to ask to answer yourself, because look, there's a rod here, so friction is involved. This thing is moving, so there is a speed involved there. Hence, the friction is also part of it. Sound is being produced, heat as well as being produced. So these are the three factors that can affect this efficiency. How come it's not 100%? It's because friction is involved there, sound, and as well as what? Heat. All these, they are making the system to lose energy. All right. So energy is being lost in those three forms: friction, heat, and sound. Cheers.